Okay, so we're given this demand function, and we're told to find the elasticity at 3 points. When the price is equal to 90, when the price is equal to 50, and when the price is equal to 1. Okay? So, remember elasticity is dq dp times p over q. And so let's first just find the sort of generic formula here. So dq dp, in this case, the derivative with respect to p is super simple. It's just -1. And then we have multiplied by q, p over q. So the generic, in this case, the sort of generic thing is depends on p and q, and we could actually go forward and substitute this in. We get -p over 100 minus p. Okay, we could substitute out that q. But you can see here that unlike in that Cobb-Douglas case, things don't just cancel out and we get just one number. And that's because for a demand curve that looks like this, oops, the elasticity is actually going to vary all along the way. Okay, the elasticity will be, I think, large up here and small down here. So let's look into it a little bit. If the price is 90, the elasticity is equal to -90 divided by 100 minus 90, which is -90 over 10 or 9, -9. Okay, so at the top, market is really elastic. Okay, this is a term we use to say when the absolute value of the elasticity is greater than 1. Okay, since it's negative, that would mean like the actual value is less than -1. It's just a big, a big number with a negative sign in front of it. Okay, when the elasticity is at 50, we get -50 over 100 minus 50, which is 50 over 50 or -1. This is a special case called unit elastic, and the Cobb-Douglas function is unusual in that everywhere it is unit elastic. It's always the case that a 1% increase in price leads to a 1% decrease in quantity and vice versa. But for lots of other production functions, that's unusual, okay? And for this one that's a straight line, it's only right in the middle that they achieve unit elasticity. The last one we were going to do was when the price was 1, and there we get an elasticity of -1 divided by 100 minus 1, or -1 over 99. Okay, this is very inelastic, meaning close to 0, or the absolute value is less than 1. And that means that a small change in that a change in the price has a very small effect on the quantity demanded. Okay, so things that have elastic demand are things that describe sort of price-sensitive customers. They can choose to buy a lot if the price is good, or they can choose to just walk away and buy very little. Okay, they may have many options. It may be a luxury good that they don't really need. Where's my marker here? There may be a lot of substitutes for the good, so that you can just go instead of buying oranges, you can buy apples and you'd be almost as happy, for example. Or it could be sort of a luxury good where it's nice to have, but you don't really care that much. Okay. And on the other side, inelastic goods were price insensitive. They're things that you've got to have, but you don't need, like, the amount that you need doesn't depend that much on the price. You just need a certain amount. Okay. So these are necessities. So things that you have to have, like food, you got to have about 2,000 calories a day, whether it costs you a lot or a little, you're going to pay it because you need it to live. But if the price of food is discounted really heavily, you're not going to consume that much more than 2,000 calories in a day. Okay. It's also good for which there's really no substitute. You got to get this or you can't get it at all. Okay. And the elasticity of demand is going to turn out to matter for things like market power when we get to later units. But at this stage, it's just sort of it's just a way that we're going to describe demand curves. We'll start to use it in future lessons. Okay.